Hi, welcome to this session, the new session lecture 2. In the previous class, we have studied mainly 5 important Laplace transformations. Laplace transform of 0 is equal to 0. Laplace transform of 1 is equal to 1 by s. Laplace transform of t is equal to 1 by s square. Laplace transform of t raised to n is equal to n factorial divided by s raised to n plus 1. Here s is greater than 0, okay? And also Laplace transform of e raised to at is equal to 1 by s minus a. These results we have discussed in the last class. So in this lecture, I would like to explain what you mean by what is Laplace transform of sine at. So we have f of t is equal to sine at. Then Laplace transform of sine at is defined as sine at is equal to integral from 0 to infinity e raised to minus st into sine at dt. E raised to minus st into sine at dt. And I can integrate this as this is the first function and this is the second function. So e raised to minus st into sin at integration minus cos at divided by a minus integral of derivative of e raised to minus st, that is minus s into e raised to minus st into integral of the sin at, that is minus cos at divided by a into dt. Okay, so this is equal to negative 1 minus 1 by a into e raised to minus st into cos at minus part minus plus again negative. So this is s divided by a integral e raised to minus st into cos at dt. Okay, so again we can integrate this as this is equal to minus 1 by a e raised to minus st into cos at minus s by a into integral of this one is e raised to minus st into integral of this one is sin at divided by a minus again this is derivative integral of minus s into e raised to minus st into sin at by a dt. So this is equal to minus 1 by a e raised to minus st into cos at minus s by a square into e raised to minus st into sin at. Then next is here it is minus plus, so again negative. So this is minus of here it is s square divided by a square into integral of e raised to minus st into sin at dt. Sin at dt. So therefore what we have got here, that is integral 0 to infinity e raised to minus st into sin at dt is equal to minus 1 by a e raised to minus st into cos at from 0 to infinity minus s by a square into e raised to minus st into sin at from 0 to infinity minus s square divided by a square into integral from 0 to infinity e raised to minus st into sin at dt. Okay, so I'm adding this to left side. So this is 1 plus s square by a square into integral 0 to infinity e raised to minus st into sin at dt is equal to what is the limit of this one, e raised to minus infinity, that will become 0 here. this is e raised to minus infinity into this one, that is 0. Again e raised to 0 apply ചെയ്ത് കഴിഞ്ഞ് കഴിഞ്ഞാൽ ഇവിടെ that's equal to minus 1 by a into. So this is the infinity when I am substituting the limit, and this is equal to minus 1 by a into, this is 0 minus. Here it will be 0, total 0. So in turn this is 1 by a. So this is 0 to infinity e raised to minus st into sine at dt equal to 1 by a into a square divided by a square plus a square. So which implies a divided by a square plus a square. So this is a formula for sine at, and this is a divided by a square plus a square. Next is we have to find out what is Laplace transform of. What is Laplace transform of cos at? Laplace transform of cos at. We have to prove that this is equal to s divided by s square plus a square. S divided by s square plus a square. We can derive this formula using the method given before. For the sin at ക്ക് നമ്മൾക്ക് ചെയ്ത അതേ മെത്തേഡിൽ ചെയ്യാം. അല്ലാതെ നമ്മൾക്ക് ചെയ്യാൻ പറ്റുന്ന ഒരു മെത്തേഡാണ്. Let's remark. That is, we have Laplace transform of e raised to iat. What is Laplace transform of e raised to at? Laplace transform of e raised to at is equal to 1 by s minus a. അപ്പോൾ e raised to iat ആണെങ്കിൽ എയുടെ സ്ഥാനത്ത് ഇവിടെ ഉള്ളത് ia. So this is 1 by s minus ia. So കോംപ്ലക്സ് കോഞ്ചുഗേറ്റ് ആയതുകൊണ്ട് ഇതിനെ താഴെ എപ്പോഴും ഡിനോമിനേറ്ററിൽ കോംപ്ലക്സ് നമ്പർ വെക്കില്ല, അതിന്റെ കോഞ്ചുഗേറ്റ് കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യാം into s plus ia. Here it is s plus ia. So this is s plus ia divided by s square plus a square. So e raised to at എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താ Laplace transform of cos at plus I into sin at. This is by using linearity property. We will prove later. That is Laplace transform of cos at plus I into Laplace transform of sin at, which implies s divided by s square plus a square plus I into a divided by s square plus a square. Okay, so from this, taking the real part, that is Laplace transform of cos at equal to s by s square plus a square, and taking the imaginary part, Laplace transform of sin at equal to a divided by s square plus a square. ഈ രണ്ട് മെത്തേഡിലൂടെയും you can prove that Laplace transform of cos at is equal to s square plus a square, and Laplace transform of sin at is equal to a divided by s square plus a square. A divided by s square plus a square. So Laplace transform of sin h at is equal to a divided by s square minus a square, where s is greater than mod a. This is we have to prove. Sin h at is actually e raised to at minus e raised to minus at divided by 2. So Laplace transform of sin h at, Laplace transform of sin h at is equal to integral from 0 to infinity e raised to minus st into sin h at dt, which is equal to integral from 0 to infinity e raised to minus st into e raised to at minus e raised to minus at divided by 2 dt, 2 into dt, which implies e raised to 0 to infinity e raised to minus st into e raised to at minus 1 by 2 taking outside e raised to minus st into e raised to minus at into dt. Okay, so this is equal to 1 by 2 into integral 0 to infinity. This is e raised to minus of s minus a. Okay, into t minus, this is minus of s plus a into t. Okay, into dt. So 1 by 2 into the integral of this one is e raised to minus of s minus a into t divided by minus of s minus a from 0 to infinity minus, this is e raised to minus of s plus a divided by minus of s plus a from 0 to infinity. So this is equal to minus 1 by 2 into, this is minus 1 by s minus a into e raised to minus of, this is actually minus of s minus a into infinity. So s minus a must be, here it is greater than 0, then only we can see that this is 0 minus e raised to 0 minus plus, that is 1 by s plus a into e raised to minus of s plus a into infinity, here it is t here, minus e raised to 0. So which implies 1 by 2 into, minus 1 by s minus a, this is 0 actually, this is 0 minus 1 plus 1 by s plus a into, this is 0 minus 1, which implies 1 by 2 into, this is minus 1 by s. So that is minus plus 1 by s minus a minus 1 by s plus a, which implies 1 by 2 into, ഇതിനെ LCM എടുക്കുക, അപ്പോൾ s square minus a square വരും, s plus a into s minus a. So here s plus a minus s minus a. So which implies what will be this one? Here it is 1 by 2 into s minus s cancel ആയി പോവും. So 2a divided by s square minus a square വരും. So 2 get cancelled and this is a divided by s square minus a square. A divided by s square minus a square. And next is Laplace transform of cos h a t. Laplace transform of cos h a t. In the same way, we have proved in the case of the sin h a t. We can find out Laplace transform of cos h a t is equal to s divided by s square minus a square, where s is greater than mod a. S is greater than mod a. And how will you prove this? That is, Laplace transform of cos h a t is equal to integral from 0 to infinity e raised to minus st into cos h a t dt, which implies integral from 0 to infinity e raised to minus st into, this is e raised to at plus e raised to minus at divided by 2 into dt. This in turn we can see that this is 1 by 2 into integral from 0 to infinity e raised to minus of s minus a into t plus e raised to minus of s plus a into t dt. After taking limit and after integrating and applying the limits, we can see that this limit will be s divided by s square minus a square. Okay, so you have to do the problems from the textbook exercise. You have to do the exercise also. Okay, thank you.